Okay, hi folks. We're going to work on our test number 3 review sheet, and I wanted to a couple of say things on the right side. I didn't finish writing this, but for instance, you got to show your work on a separate sheet of paper. Don't skip any steps. No work, no credit. I know a lot of you guys might be using photo math. Not a lot of you guys, but maybe to check your answers. Yeah, check your answers. But the goal of all the work I give you guys is to make sure you learn it for next year. And I'm giving you guys time now so you guys will be prepared for geometry and algebra 2. So you won't be like, oh, I forgot that skill. I didn't know that skill because I cheated my way through this. So make sure you write out and show all the work, because I'm going to ask you guys to take a photo of that work and to send it to me. And I'll give you guys an email. There's no calculators for this test. The reason why is because most of the numbers can be broken down by just dividing by 2 or 5 or 3, some basic number. And at the end of this test, you're going to email email me your work. Okay, and I'll post the email to the link on our Schoology website. Okay. So let's get started. We're gonna go over these questions. If you get stuck or have any questions, please definitely raise your hand and ask. So let's do question number 1. Question number 1 says negative square root of 112. Now, to show you, I'm going to write up a lot of work to show you I know what I'm doing. If I just use photo math, it's going to give you the answer, and it's not going to help you. So I want you guys to make sure you guys draw the box. And the idea is I don't know what numbers break up 112. So we're going to take our time. We're going to say 112. What's the easiest number we can divide 112 by? I see that's even. That's going to be a 2. 2 goes into 11, 5 times, remainder 1. 2 goes into 12, 6 times. Hey, I can divide 56 again by the number 2. 2 goes into 5, 2 times, remainder 1. 2 goes into 16, 8 times. Let's keep going. We can divide 28 by 2 again. 2 goes into 2, 1 time. 2 goes into 8, 4 times. And if you want to double check, isn't 2 times 14, 28? Make sure I did that right. And then let's break up 14 by 2. That goes into 7. And if you notice, I don't draw a box. You can only draw a box if you can divide it. Don't just start automatically drawing boxes. Now radicals, always take out pairs. This. So we have a pair of 2's and a pair of 2's. So these guys get kicked out. So it's negative 2. I have 2 2's. And what number is left over? So let's write that with black. It's negative 2 got kicked out, right? And we have another 2, just to write that. And we have a leftover 7. Only pairs come out. We can multiply these. 2 times 2, it's negative 4 radical 7. And that's our answer. A, B, C, or D. So if you notice, I showed a lot of work to get there, and I expect you guys to be able to show that amount of work also. Okay, question number 2. Negative square root of 250 a to the 7 and b cubed. Now square roots are always looking for pairs, right? These are square roots, are pairs. If I was looking for sets of 3 cubes, what am I writing? Cubes, this would be with a little 3 in front. So by default, we're always looking at pairs by default. So let's go ahead and look for our pairs. So I see 250, a to the 7, and b cubed. Well, let's do the number first. I don't know what the square root of 250 is, so let's break it down, looking for values that we have in common. Smallest number I can divide 250 by is a 2. 2 goes into 2, 1 time. 2 goes into 5 2 times, because that's 4. Remainder 1. That makes 0 becoming a 10. And 2 goes into 10 5 times. Okay, I see 125. I can't divide that by 2. So let's use a different number. I see a 5 at the end, so we can divide that by 5. 5 goes into 12. 5 doesn't go into 12 exactly, but we can get close with 10. So that's 2 times. Remainder 2. And then 5 goes into 25 5 times. Let's keep on going. 25 is 5 and 5. Do we have any pairs? So you can circle this 5, or you could circle this 5 if you wanted to. Right? Circle whichever 5 you want, but it's gonna leave us with the same amount of values left over. So remember, the 5 gets kicked out. So also don't forget we have negative. So negative 5 is on the outside. Now what's left over on the inside? Well, 2 wasn't kicked out, and 5 wasn't kicked out. And we multiply it back to become 5 times 2 is 10. Okay. Now, let's take a look at the other things that were in here. 250 wasn't the only number there. We also had a to the 7th and b cubed. Well, if I write those out, b7, let me erase some of these lines. Or a to the 7th, let's go. A to the 7th. A to the 7th is really 1, 2, 3, 4, 5, 6, 7. So we're looking for pairs. That's a pair, that's a pair, that's a pair, and we have 1 left over. So if you want to take your time writing this out, we can say we have, right up here, we have 1 pair of A's, we have 2 pairs, we have actually 3 pairs of A's. Oops, I'm sorry, I wrote that in the wrong place. We have, these are taken out. We have 1, 2, 3 pairs of A's. So I'm going to move all this over, giving me some space. We said that was 10. Giving me some space here too. We said we had A, and A, with 1 A left over. All right, this guy's left over here. A times A times A is A cubed. On the backside for B, let's do B now. B is right here, that's right, B, B, B. I see 1 pair, so that pair comes out to B with 1 left over. Okay, that's our answer. Take a look on the left. What's your answer? Okay, so let's go ahead and do question number 3. We're looking at the negative square root of 162 r to the 6 s cubed t squared. So my version of these questions are similar to yours. Not exactly the same. I just wanted to give you guys an example going through them all. So these are 1, 2, 3, 4 things inside this radical. So we can do them separately. So we first do the square root of 162. And we don't know what that is, so I'm going to draw the box method, 162. 2 goes into 16 8 times. 2 goes into 2 1 time. We're left with 81. If you know, that's square root of 81 is just 9. So if you want, you can jump there and we can say we're done, we're with 9. But if you don't know, let's go take our time. That's the smallest number I can divide by 3. How do I know that? Well, we had a rule for 3, 8 plus 1. If you add them up, if I can divide the new number by 3, we're golden. So that means the original number, 81, can be divided by 3. 3 goes into 8 2 times, remainder 2, because that's 3 times 2 is 6. 6 plus 2 is 8. 3 goes into 2, no, 3 goes into 21 7 times. I know I can divide 27 by 3. That's going to be 9, and 3 and 3. Let's look at our pairs. We have a pair of pair of 3s, and another pair of 3s. So we get to remove 2 3s out. So on the problem, we get to kick out 2 of these 3s. So we have a 3 on the outside, we have a 3 on the outside. What's left over on the square root? Oh, poor 2. 2 is stuck on the inside of the radical. And that's fine. Remember, you need always a pair to come out of the radical. Our next problem is, let's look at r is r to the 6. So we're going to write it out as 1, 2, 3, 4, 5, 6. Now this is a long way of doing it, but it's a way for us to see it. And looking for pairs, I have 1, 2, 3 pairs. That means they all came out. No leftovers. 1 R, 2 R, 3 R's. So we don't have to write R inside because there are no leftover R's. Let's look at S. S is, I'll write it up here. S, S, S. Remember, square roots can only take out pairs. I have a pair. That's going to be 1S comes out and 1S gets stuck in. 1S out, 1S in. And the last one, T. I have 2 T's. Well, I do have a pair, and that comes out. Rewriting this off, we end up with negative 9R cubed S and T, because they're both singular. Left over inside the square root is 2S. So it's really just taking out the pairs. If you have a pair, you take it out. If you don't have a pair, we leave it back in. Now we're just practicing that skill. For fractions, first thing you want to do is want to see if you can separate them. Negative square root of 116. Oops, my square root's a little too short. Square root of 116 over 121. Now, I see 121, I see 116, and do I know the square root of either of these numbers? And the cool thing about square roots is that you can always separate them into 2 separate square roots to make your life a little easier. And treat them separately. And treat this one separately. 2 separate problems. So if we take that approach, let's see, do we know what the square root of 116 is? Well, let's show the work. 116. Sorry, 116. I miswrote that one. 116. I can divide this by 2 for sure. Divide by 2. 2 goes into 11 5 times, remainder 1. 2 goes into 16 8 times. Let's do that again. 2 goes into 5 2 times, remainder 1. 2 goes into 18 9 times. And then 27 is a prime number, so we're done. So to rewrite that, we have a pair of what? A pair of 2's. That gets thrown out. And 29 gets stuck inside. Now, how about 121? Well, if you guys remember, the square root of 121 is actually 11. Now, once you rewrite the square root, as long as the square root is not on the denominator, on the bottom, we're good. So that's our answer. Oh, don't forget the negative sign, I'm sorry. Once the square root's not on the denominator, we're good. We can't have square roots on the denominator. And that's what you practice a lot in your IXL. Next problem is just another practice, a very similar concept. Square root of 23 over 49. Well, do I know what the square root of 23 is? Do I know what the square root of 49 is? Well, 23 is square root of 23. But the square root of 49, we do know what that is. That's just 7. So radicals can be pretty simple. Just break them apart and see if you can take the radical of them separately. Problem number 6, same idea. Now throw a variable in there. The square root of 125 x to the 7 over 144. And we break this up into 1, 2, 3 things. So do we know what the square root of 125 is? Well, I don't know. Let's write it out. 125. Smallest number I can divide is 5. 5 goes into 12 2 times, remainder 2. 5 goes into 25 now. See, that's 25. It's 5 times. I'm going to break up 25 to 5 and 5. And don't write the box unless if you can divide it. And I can't divide 5 by anything by itself. So we look for pairs now. Any pairs? I see a 5 on the outside and a 5 on the inside. Right? 5 on the outside, 5 on the inside. Because I don't have a pair. All over, and the square root of 144 is just 12. Let's do the x's. I'm sorry. Let's do x's. 1, 2, 3, 4, 5, 6, 7. Looking for pairs. Pair, pair, pair. And this guy's a loner here. So we have 3 x's. So x cubed. That's how we write. We have 3 of them. And we have 1 left over. So let's look at question number 7. Number 7 becomes a little more complicated. A lot more stuff is going on. 256 over 100 and r to the 8. Now again, we want to break this up into separate problems. That's a radical, that's a radical, that's a radical. Each of them get their own radical. Do I know what the square root of 256 is? Do I know what the square root of 100 is? Do I know what the square root of r to the 8 is? Well, the square root of 256 is going to be 16. 16 times 16 is 256. The square root of 100 is 10. And the square root of r to the 8, 1, 2, 3, 4, 5, 6, 7, 8. Pair, 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 pair. I actually have 4 pairs, r to the 4th. Now we just have to rewrite it. The square root of 256, which is on top, is just 16. The square root of 100, which is on the bottom, so that just goes on the bottom. And r to the 8, that's on the bottom. And r to the 4th. Oh, sorry. Yeah, and then, but if you look at my answers here, none of those actually fit. So if we reduce it, if you look at the 10 and the 16, we could reduce those. What can we divide 10 and 16 by? Divide them both by 2. 16 divided by 2 is 8. And 10 divided by 2 is 5. And that's our answer. So you're supposed to be able to do these problems this quickly. On the SAT, they're going to give you only a minute to do these easy questions, and so you can save your time for the harder questions. So we want to make sure we can practice these questions and we can do them quickly. So question number 8, 5 over 100. So again, we take the square roots of them separately. Do we know what the square root of 5 is? Do we know what the square root of 100 is? Well, square root of 5, that's a prime number, so we're going to leave it. But do we know what the square root of 100 is? We do, that's just 10. We're done. As long as you don't have a square root on the bottom, we're good. Now our next question reflects that. Number 9 says 13 over square root of 5. Now if you look at square root of 5, that is a no-no. We said we can't leave square roots on the bottom. This is bad on the bottom. On the top is fine. See, on the top over here, that's okay. But on the bottom is no-no. So we have a trick. The trick is multiplying by exactly the same thing. If it's just a regular square root by itself, not a binomial, not two things, one thing, meaning there's no plus or minus sign, then we multiply the same square root to the top and bottom. A square root and a non-square root stay separate, right next to each other, and square root of 5 times square root of 5 is square root of 25, and that gives us basically just back to 5. Now this happens for any type of number. If I write, let's say 6 over square root of 3, well, that's going to be 6 over square root of 3, and we're going to multiply by square root of 3 to the bottom and the top. That becomes 6 square root of 3 over 3. In this case, we could reduce by 2, so by 3, so we're left with 2 square root of 3. So you got to practice that. And then the IXL problems allow you guys to practice that very quickly. Let's do this one. Homework question number 10. That's the square root of 7b to the 4th over 5. And we're going to say, well, what's the square root of 7? What's the square root of b to the 4? What's the square root of 5? Can we do any of these? So square root of 7, square root of b to the 4th, and square root of 5. And turns out we can't do square root of 7. That's still stuck there. Square root of b to the 4th, that's b squared, because I have 1, 2, 3, 4, 2 pairs. And square root of 5 is square root of 5, so we can't change it. So if I rewrite it, we have b squared square root of 7 over square root of 5. Now, are we okay with square root of 7? Are we okay with square root of 5? Which of these are a no-no? Square roots on the top or square roots on the bottom? We said before, square roots on the bottom are a no-no. So we're going to multiply by square root of 5 to the bottom and the top. Now, square roots can multiply square roots. 7 times 5 is going to be square root of 35. And square root of 5 times square root of 5, we said we're free, 5. Now, we can't divide these. We can't just divide those because one's inside the square and one's outside. So we're done. Always check if you can reduce. 11 is a different type of problem, so we're going to work on that real quickly. Okay, for question number 11, this is a fraction type. Now, when we're looking at these fraction types, we have to be careful because we're not allowed to have square roots on the bottom, but this is a special type of square root. There's two terms, it's a binomial. So we had a special way of doing this, and we practiced this on IXL again. So if you need more practice, go back to the IXL and do this problem. It's dividing rationals. So if I write it, we taught that the special way of getting rid of this square root is to actually multiply both of them by what we call the conjugate. And the conjugate says instead of 1 minus square root of 6, 1 minus square root of 6, we are going to instead do 1 plus square root of 6 to the top and bottom. Very similar to what we did back here with other square roots. When we had a square root on the bottom and the top, so on the bottom, we multiplied by the same square root. But in this special case, we are going to multiply by not the negative version, but the positive version. And you always change that middle sign. And that's the easy hint there. We always change that middle sign. So the negative became a positive. And if this was positive, this would become negative. And you multiply it to the top and bottom. So we go ahead and practice the skill. We multiply, that's 10 times 1 is 10, and 10 times square root of 6 is 10 square root of 6, that's on top. On the bottom, we take our time. Say 1, so we can do this on the side if you want to save some space. 1 times 1. I'm going to erase this so you see a little clear picture. The conjugate. We're going to take 1 times 1 is 1. 1 times square root of 6 is a positive, and a positive is a positive square root of 6. We then follow up with square root of 6 times 1 is negative square root of 6. And negative square root of 6 times square root of 6, that's a negative 6. Because the square root of 6 times the square root of 6, right, times square root of 6 is square root of 36. Or we could just jump to say that's 6. Now, we do have like terms here, right? These are like terms. So it turns out these always will cancel out. Because of the plus and minus that we said here, the middle terms will always cancel out. Now take a look at that again. Does it look like they're going to cancel out? A positive square root of 6 and a negative square root of 6, since they're exactly the same, they always cancel out, getting rid of that square root symbol. And we just have 1 minus 6, leaving us negative 5. When we rewrite the problem, we have a 10, 10, and a 5, and a square root of 6. Now, we could always divide out. If I can divide everything outside the square root by the same number, and I can divide them all by, what, 10, 10, and 5. I can divide them all by 5. 10 divided by 5 is 2. 10 square root of 6 divided by 5 is 2 square root of 6. And square root of 5 divided by square root of 5 is a negative 1. We're going to multiply this negative 1 to the top. So negative 2 minus 2 square root of 6. So whenever we have a radical on the denominator, we have to get rid of it. Now, just on the side question, let's give you another example. If I say 11 over 3 plus square root of 7, what do you think the conjugate's going to be in this case? What am I going to multiply here? Okay. It's almost like its exact twin, except not plus, we're going to write minus instead. Okay.
And just to practice that bottom part, 3 times 3 is 9. 3 times negative square root of 7, that's negative 3 square root of 7. We're done with the 3. Let's do the square root of 7 now to the front and to the back. That's going to be plus 3 square root of 7 plus square root of 7 times square root of 7. Oh, that's not plus. Square root of 7 times square root of 7 is just a regular 7. It's a regular 7. And it's going to be a minus 7. Look at these terms in the middle. Look at these terms. We have a plus version and a negative version, right? Plus version, negative version. They cancel out. They always cancel out. They mean just a 9 minus 7, which is 2. So we know the bottom for sure is just going to be 2. If we distribute the 11 to the top, that's 33 minus 11 square root of 7. Because 3 times 11 is 33. And 11 times square root of 7 is just 11 square root of 7. Okay, that's just another side example. Okay, we're almost there. Our next question here is, what if I have 2 square roots on the bottom? If I have 2 square roots on the bottom, we have to multiply them both the square root. So just like what we did before, we copy the exact same problem on the denominator. Right? In our last problem, we said it was going to be 3 square root of 7, 3 square root of 7. So we wrote that on the bottom and the top. Well, here we have a square root and square root, so we write that exactly the same thing. But since this is a conjugate, remember the word conjugate, that negative becomes a positive to both the top and the bottom. Now we take our time multiplying it out. The top is 15 times square root of 2 is 15 square root of 2, because the outside and inside stay separate. 15 times square root of 5 is plus 15 square root of 5. Now the bottom, let's go take our time over here. We'll do front, back, distribute property, multiplying everything out. So it's going to be square root of 2 times square root of 2 is square root of 4, which is just 2. Save yourself the time. Just write square root of 2. Oh, square root of 4 is just 2. Our middle terms will be plus square root of 10 minus square root of 10, because 2 times 5 is 10. 5 times 2 is 10, but this one's going to be negative. And negative square root of 5 is square root of 25. And square root of 25 is just... What happens to the middle terms? What will always happen to the middle terms if I multiply by the conjugate? The middle terms cancel out. And we're left with a negative 3. Now can I divide? Now that we have this problem here, we're pretty good shape. But can I still reduce? Can I reduce the 15? All the numbers outside the square root. Can I reduce the 15, and the 3? What number can I divide them all by? Well, I can divide them all by 3. So 15 divided by 3 is 5. 15 divided by 3 is 5, all over negative 1, and I can move the negative 1 on top. So we have to distribute to the front and the back. It's a negative 5 square root of 2 minus 5 square root of 5. And that answer wasn't obvious. Okay, so let's just do another side question. 15, well, let's not do, I'm sorry, 15. Let's do 6 over square root of 3 minus square root of 2. What do you think the conjugate's going to be here? Square root of 3, square root of 2, square root of 3, square root of 2. Instead of a negative though, right, instead of a negative, we're going to use a positive. Okay? And just, so here's the fast route. Since we know the middle term will cancel out, we just do the front. Square root of 3 times square root of 3 is positive 3, and square root of 2 and square root of 2 is going to be 2. And don't forget, the negative and positive become a negative sign. And that's 1 on the bottom. You just got to do the top. 6 times square root of 3 is 6 square root of 3. 6 times square root of 2 is 6 square root of 2. So just practice that a couple of times. You might see this on the SAT, and for sure you'll see this in Algebra 2. The last question here we've worked on again in IXL, number 13, is 6 square root of 27 minus 3 square root of 3. Now, can I combine them, since one is the square root of 27 and one is square root of 3? Since they're not like terms, we can't. So we're going to see, can I simplify square root of 27? 27. Let's draw them in a box. I can divide 27 by 3, I know that. 9 times 3 is 27. And then I can break up 9 by 3 and 3. So we do have a pair. That's what we always do with squares, looking for pairs. So this is 3 square root of leftover 3. So if I wrote, so we had a 6 on the outside, so it'd be 6 times 3 square root of 3 minus 3 square root of 3. These are multiplying each other since they're both outside next to each other. That's 18 square root of 3. Numbers, when they're next to each other, are always multiplying. Only time you add is when you have a plus sign. And then we can combine those to become 18 square root of 3 and 3 square root of 3. Hey, look, they're both like terms now because they both have a square root of 3. 15 square root of 3. Okay. Let's do another similar question to this. I say 5 square root of 8 minus 4 square root of 2. Hey, do these square roots match? But can I break up square root of 8? Oops. Uh-oh. Square root of 8 is really, I can divide 8 by 2. Divide 2 and 2. Circular pair. That's going to be 2 square root of 2. Bring it back into the problem. 5 times 2 square root of 2, because this became, square root of 8 became 2 square root of 2. Hey, you gotta multiply those together. 10 square root of 2 minus 4 square root of 2 is 6 square root of 2. Okay, just to practice that. Okay, go ahead and good luck on this worksheet. This is just, again, practice reviewing all the IXL problems that you've had.